Welcome to our deep dive into the history of the plurality of worlds concept. Um, you've probably heard about the possibility of countless Earth-like planets and alien civilizations out there. It's a captivating idea, but you might be surprised to learn that it's been consistently challenged by scientific evidence throughout history.
Yeah, it's a fascinating paradox, isn't it? The human imagination often leaps ahead of what we can empirically verify. Today, we'll examine how three prominent scientists, Johannes Kepler, Jacques Cassini, and William Whewell, each in their own time, used the most advanced science available to question this popular notion of a universe teeming with other Earths and intelligent life.
So let's start with Johannes Kepler in the 17th century now. Kepler's a fascinating figure because while he believed in extraterrestrial life, even speculated about intelligent beings on Jupiter, he firmly opposed the idea of multiple suns. Why was that?
Well, Kepler's reasoning was rooted in a simple but profound observation, the striking difference in brightness between our sun and the distant stars. He argued that if the stars were truly suns like ours, they would have to be unbelievably massive to be so far away and yet still appear so faint.
So he was essentially saying that based on the observed dimness of the stars, they couldn't possibly be suns like our own.
Exactly. He even used a powerful analogy to illustrate his point. Imagine sunlight streaming into a sealed room through a tiny pinhole. That pinhole of sunlight would instantly outshine all the stars in the night sky. This stark contrast in brightness, Kepler argued, demonstrated that stars must be fundamentally different from our sun.
That's a vivid way to emphasize the disparity in brightness. But didn't Kepler also back up his argument with some specific calculations?
He did. Using the accepted measurements of star sizes at the time, he calculated that a star like Sirius, to appear as dim as it does from Earth, would have to be larger than Saturn's orbit. And this logic he extended to all visible stars, suggesting they were all enormous, unlike our sun.
So according to Kepler, the universe had only one true sun, ours, despite the existence of other celestial bodies. This contradicted the growing popularity of the plurality of worlds concept, didn't it?
Yes, it did. Around this time, the idea of multiple Earths was spreading rapidly across Europe, fueled by Bernard Le Bovier de Fontenelle's 1686 book, Conversations on the Plurality of Worlds. This book sparked the public's imagination with vivid descriptions of other planets inhabited by intelligent beings, capturing the essence of a universe teeming with life.
It sounds like an early form of science fiction, captivating the public's imagination. And there's a specific illustration in the book that really encapsulates this whole plurality of worlds concept, right?
You're thinking of the frontispiece. It depicts our solar system as just one among many, showcasing a universe filled with countless star systems, each potentially harboring life. This visual representation played a crucial role in popularizing the concept.
It's interesting how a single image can be so powerful in shaping public perception. But you mentioned earlier that this growing popularity of the plurality of worlds might have been influenced by factors beyond scientific curiosity. There was a political dimension to it, wasn't there?
Yes, there was. Historian Lucia Ayala argues that the rise of pluralism, as this concept is often called, can be seen as a subtle challenge to the authority of King Louis XIV of France, the Sun King.
Ah, yes, the Sun King. He was all about using the single sun imagery to bolster his rule, wasn't he?
Precisely, Louis XIV embraced the Copernican model, which placed the sun at the center of the solar system as a metaphor for his own absolute rule. He saw himself as the sun radiating power over his kingdom. The idea of multiple suns, each potentially with their own sun kings, could be seen as undermining his claim to unique and unrivaled authority.
So the popularity of pluralism, with its multiple suns and worlds, might have been in part a pushback against this centralized view of power.
That's the argument Ayala puts forward. It's a reminder that scientific ideas are often intertwined with social and political contexts.
While Fontenelle's book sparked public imagination, did his work hold up to scientific scrutiny? Was it based on solid evidence, or was it more speculative in nature?
Well, while Conversations on the Plurality of Worlds was a captivating read, its scientific accuracy was debatable. For instance, Fontenelle attributed the twinkling of stars to the interaction of swirling vortices around stars, even though astronomers already knew this was an atmospheric phenomenon. This demonstrates that the popularity of an idea doesn't always equate to its scientific validity.
It seems like the scientific foundation of pluralism wasn't always as strong as its popularity might suggest. But wasn't there another scientist who challenged this idea based on precise measurements, moving beyond speculation?
Yes, a few decades after Fontenelle, Jacques Cassini, working at the Paris Observatory, made meticulous telescopic measurements of Sirius's apparent diameter. His findings were significant because they confirmed what Kepler had argued earlier. Sirius was indeed a giant star.
So Cassini's observations provided further evidence that if stars were indeed suns, they had to be immense, much larger than our own.
Precisely. Given the prevailing understanding of star sizes and the vast distances involved in a Copernican universe, Cassini's measurements implied that stars had to be colossal to appear as bright as they did from such incredible distances. This again contradicted the idea of stars being simply suns like ours, each potentially harboring a system of planets.
It's fascinating how even precise measurements like Cassini's weren't enough to deter the allure of the plurality of worlds concept. It seems the idea's appeal was strong enough to withstand conflicting evidence.
It highlights a crucial point about the nature of scientific progress. It's not always a straightforward path from observation to conclusion. Sometimes even accurate measurements can be misinterpreted, especially when our understanding of fundamental concepts is still evolving.
What do you mean by that? Were Cassini's measurements flawed in some way?
Well, his measurements were precise for his time, but they were based on a flawed understanding of how telescopes worked. Back then, astronomers believed that the disks they saw when observing stars through telescopes represented the actual physical size of the stars. They didn't realize that these disks were optical artifacts known as Airy disks, caused by the wave nature of light.
Airy disks. Could you elaborate on that a bit more?
Of course, Airy disks are diffraction patterns that occur when light waves pass through a circular aperture, like the lens of a telescope. They create a bright central spot surrounded by fainter rings, making stars appear larger than they actually are. It wasn't until the 19th century, with the development of the wave theory of light, that this misunderstanding was cleared up.
So while Cassini's measurements were accurate, they were ultimately based on a misconception about how light interacts with telescopes.
Yes, but this is a great example of how science is an iterative process. New discoveries often challenge our existing assumptions, leading to a refined understanding of the universe. It's not about being right or wrong all the time, but about continuously refining our knowledge based on the best available evidence and theories.
This is a great reminder that science is a journey of exploration and discovery, full of twists and turns. But how does this story of challenging the plurality of worlds continue? What new developments arose in the 19th century?
Yeah, as we move into the 19th century, we see a shift in focus. While the size of stars remained a point of contention, the debate expanded to encompass the growing understanding of planetary diversity and its impact on the likelihood of widespread intelligent life.
So instead of just questioning if stars were suns like ours, scientists were now asking if planets themselves could support life as we know it. It's a more nuanced approach to the question of extraterrestrial life.
Exactly, and this is where William Whewell enters the scene. Master of Trinity College, Cambridge, Whewell was a true polymath with expertise in geology, philosophy, and importantly for our discussion, astronomy. In 1853, he anonymously published a groundbreaking essay of the plurality of worlds, which directly challenged the assumption of a universe teeming with intelligent life.
It seems Whewell was approaching this question from a unique perspective, drawing on his diverse scientific background. What were some of his key arguments against the plurality of worlds?
Well, one of Whewell's most significant contributions was his argument based on the inverse square law, a fundamental principle in physics. This law states that the intensity of light and heat decreases rapidly with distance from the source. Think of it like this: if you move twice as far away from a light source, the intensity of the light decreases by a factor of 4.
So Whewell applied this law to the context of planets orbiting stars, suggesting that only planets within a very specific distance range from a star could receive enough light and heat to potentially support life.
Precisely. He was essentially one of the first to articulate the concept of a habitable zone. Around a star, a region where conditions might be just right for liquid water to exist on a planet's surface, a prerequisite for life as we know it.
It's fascinating how this concept, first proposed by Westwell in the mid-19th century, is now a cornerstone of modern astrobiology. We use the habitable zone concept to guide our search for potentially life-bearing exoplanets even today.
It speaks to the enduring power of scientific insights. But Westwell didn't stop there. He drew on his expertise in geology to further challenge the plurality of worlds idea. He argued that even if other planets exist within their star's habitable zones, the presence of intelligent life is far from guaranteed.
How did he connect geology to this question of extraterrestrial life?
Well, as a geologist, Westwell understood that Earth itself was devoid of intelligent life for the vast majority of its history. If our planet, a seemingly ideal environment for life, took billions of years to develop intelligent beings, then it's plausible that other planets, even if habitable, might not be teeming with intelligent civilizations.
That's an important perspective. It suggests that finding a planet in a habitable zone is just the first step. The development of intelligent life might require a complex interplay of factors and a vast amount of time.
Exactly. And this leads us to another significant development in the 19th century, the demise of the spontaneous generation theory. This idea, widely accepted for centuries, held that life could arise spontaneously from non-living matter.
I recall learning about that in school. The classic example is frogs supposedly emerging from mud, a belief that seems absurd to us now.
Yes, it was a common belief, and it fueled the plurality of worlds concept, because if life could spring forth from matter anywhere, then it would logically exist on other planets.
It simplifies the whole question of life's origins. No need for special conditions or intricate processes, just life emerging spontaneously from matter wherever it might be found.
But the 19th century saw a decisive shift away from this idea. Experiments like those conducted by Louis Pasteur demonstrated that life doesn't simply appear from non-living substances. These experiments play a crucial role in debunking spontaneous generation, suggesting that life's origins are far more complex than previously thought.
So these experiments were crucial in overturning a long-held scientific belief. How did this new understanding impact the plurality of worlds debate?
It added another layer of complexity to the search for extraterrestrial life. If life didn't just arise spontaneously, then the conditions required for its emergence might be far more specific and less common in the universe.
It shifts our focus from the abundance of matter to the unique conditions and processes that might be needed to spark life into existence, suggesting that life, especially complex life, might not be as widespread as previously thought.
Right, this shift in understanding combined with the growing awareness of planetary diversity painted a more intricate and nuanced picture of a universe where life might be far less common than previously assumed.
You mentioned planetary diversity. What were some of the scientific developments that led to a greater understanding of the differences among planets?
Well, even back in the 17th century, astronomers like Christian Huygens were starting to recognize that planets are not simply scaled up or scaled down versions of Earth. They exhibit a remarkable range of sizes, densities, and compositions.
Do we have any specific examples of how this early understanding of planetary diversity was represented?
In 1698, Huygens published a diagram in his book Cosmotheros, which illustrated the relative sizes of the planets and the Sun. This diagram, while simple by today's standards, clearly demonstrated the vast differences in size among the planets, from tiny Mercury to gigantic Jupiter.
So even before we had sophisticated telescopes and space probes, scientists were starting to grasp the sheer variety of planets that might exist.
Yes, and this understanding was further bolstered by the groundbreaking work of Isaac Newton. In his monumental work, The Principia Newton included calculations that revealed significant differences in mass density and surface gravity among the planets. This further emphasized that planets are not uniform entities, but diverse worlds with unique properties.
These scientific insights were painting a picture of a universe far more complex and varied than previously imagined. But how did the scientific community begin to explore the composition of stars and planets, moving beyond simply measuring their size and distance?
That's where the field of spectroscopy comes, and this powerful tool developed in the 19th century allowed scientists to study the composition of stars by analyzing the light they emit, and what they discovered was astonishing stars, while sharing some similarities with our sun, actually exhibited a wide range of compositions and temperatures.
So it wasn't just about size anymore. It was about recognizing that stars are not simply bigger or smaller versions of our sun. They are fundamentally different in their makeup, suggesting incredible diversity across the cosmos.
Exactly, and this understanding of stellar diversity was further advanced in the 20th century by astronomers like Henry Norris Russell.
So we've been talking about Henry Norris Russell. What did he add to the conversation?
Well, Russell developed a classification system for stars based on their luminosity and temperature. This system, which we still use today, is known as the Hertzsprung-Russell diagram. It visually represents the incredible variety among stars, ranging from massive hot blue giants to small, cool red dwarfs.
It sounds like the Hertzsprung-Russell diagram is like a cosmic family portrait, showcasing the full range of stellar personalities out there. This must have had a huge impact on the search for other Earths, right?
Absolutely. The Hertzsprung-Russell diagram revealed that our sun is not just any star, it's a relatively stable and long-lived star, a yellow dwarf. These characteristics have been crucial to the development of life on Earth.
So it's not enough to just find a planet within a star's habitable zone. The star itself needs to have the right characteristics to support life over long periods, adding yet another layer of complexity to the search for other Earths.
Exactly. And this brings us to the late 20th century and one of the most significant breakthroughs in the search for extraterrestrial life, The discovery of the first exoplanets in the 1990s, these discoveries revolutionized our understanding of planetary systems. What's fascinating is that they revealed even more diversity than we could have imagined.
So we're moving beyond theoretical debates about the size and composition of stars and planets, and we're actually starting to observe planets orbiting other stars.
Yeah.
What kind of diversity are we talking about here?
We're talking about a menagerie of planets unlike anything we see in our own solar system: hot Jupiters, super-Earths, mini-Neptunes, and even rogue planets wandering through interstellar space. It seems our cosmic imagination wasn't even close to capturing the true variety of planets out there.
It's a testament to the power of scientific observation. We
Right.
can speculate all we want, but ultimately it's the data, the direct observations that reshape our understanding of the universe. But this incredible diversity also raises a crucial question. If planets are so varied, what does this mean for the likelihood of finding life, especially intelligent life?
Well, that's the question that drives so much of modern astrobiology. It's a delicate balance between hope and realism. We're driven by the tantalizing possibility of finding life elsewhere, but we also have to confront the growing awareness that the conditions required for life, especially complex life, might be incredibly specific and perhaps even rare in the vast expanse of the cosmos.
It's a humbling thought, isn't it? It makes you appreciate just how special and precious life on Earth is. But it also makes me wonder how we reconcile this growing awareness of cosmic diversity with our enduring fascination with the idea of other Earths and extraterrestrial life. Throughout history, we've seen how this idea has captured the human imagination, often outpacing the scientific evidence.
It's a question that delves into the core of what it means to be human. Our innate curiosity, our desire to explore the unknown, and our yearning to find connections beyond our own world drive us to search for life beyond Earth. We're storytellers by nature, and the idea of alien civilizations, perhaps even visiting Earth, is a powerful narrative that resonates deeply with us.
While the possibility of advanced alien civilizations is a captivating idea, it's important to remember that science is about evidence, not just speculation. And as we've discussed, the scientific evidence suggests that the conditions required for complex life might be far rarer and more specific than we once thought.
That's right. The search for life beyond Earth is not simply about finding another planet just like ours. It's about understanding the full spectrum of life's possibilities, from the simplest microbial life to the potential for complex, intelligent beings.
So we're expanding our definition of life beyond what we're familiar with. It's about acknowledging that life might exist in forms we can barely imagine, perhaps thriving in an environment that we would consider extreme.
Exactly. We might find microbial life flourishing in the icy plumes of Saturn's moon Enceladus, or extremophiles surviving in the harsh conditions of a volcanic exoplanet. These discoveries, while perhaps less dramatic than finding intelligent aliens, would be monumental in their own right.
That would force us to reconsider our anthropocentric view of life, expanding our understanding of its resilience and adaptability. And they might provide clues about the origins of life itself.
Precisely. Every new discovery, every piece of data we gather helps us piece together the intricate puzzle of how life emerged on Earth and potentially elsewhere in the universe.
So while we may never encounter those advanced alien civilizations we've dreamt of, the search for life beyond Earth remains a profound and exciting endeavor.
It's a testament to our insatiable curiosity, our desire to understand our place in the vast cosmic tapestry. Who knows what incredible discoveries await us? As history has shown us, the universe is full of surprises, often exceeding even our wildest imaginations.
Well said. This deep dive into the history of the plurality of worlds has been a fascinating journey. We've seen how this enduring idea has been challenged and refined by scientific progress, leading us to a more nuanced and awe-inspiring understanding of the universe and the potential for life beyond our own planet. It's a reminder that the pursuit of knowledge is a continuous process of discovery driven by our innate curiosity and our desire to unravel the mysteries of the cosmos.
And perhaps the most important lesson we can take away from this exploration is that while scientific evidence might challenge our preconceived notions, it also opens up new avenues of inquiry, leading to a richer and more profound appreciation for the incredible diversity and complexity of the universe.
It's a reminder that the universe is not just a backdrop for our human stories. It's a vast and intricate tapestry of wonder, full of mysteries waiting to be unraveled. And that's what makes the pursuit of knowledge so endlessly fascinating. Thank you for joining us on this deep dive. We hope you'll continue to explore questions and seek out those hidden truths that lie beyond our world.